Hello everyone. I hope everyone is doing great. So today in this particular tutorial is the continuation of the second part of basic statistics. So two topics were left in the last tutorial, which is Z-score and sampling methods. So I will be covering them both today. So let's start with Z-score. So in the last tutorial, you have a little bit of idea about Z-score, right? So we discussed about standard normal distribution in the last tutorial. If you guys have not gone through my last video, I would request you to please go through it so that it will be easier for you to understand what I'm trying to say in this tutorial. So standard normal distribution is that distribution whose mean is 0 and standard deviation is 1. So if you draw it, the mean is 0 and the standard deviation is 1. Okay. So -1, -2, -3, like that. And this is the mean. This is the mean and this is the standard deviation. So each numbers on the horizontal axis corresponds to Z-score. All these numbers correspond to Z-score. What it tells? Z-score basically tells us how many standard deviation away is our observation from the mean. Let's say a Z-score of -2.5. Let's say Z is -2.5 here. Let me mark it with a different color. So it says that this observation is 2.5 distance away, standard deviation, sorry, not distance, 2.5 standard deviation away from our mean on the left hand side. On the left hand side. So similarly, if Z-score of 2, which is this one, it means our observation, so this is observation, is 2 standard deviations away from the mean on the right hand side. This is how we define Z-score. Also, one thing to notice and one important factor is Z-score also tells us the area which is under that particular score, or area is also associated with Z-score. For example, Z-score of 2 means this area. So it means this area. This is the area under the curve for a Z-score of 2. Similarly, and it's on the left hand side. For example, for this one, for Z-score 2.5, -2.5, the area is this one. So this is the area under the curve for the Z-score of -2.5. And this is the area under the curve for the Z-score of 2. Okay, we also write it as proportion of the area less than 2 is this area. Whatever calculated value that we'll get for this area. So let's say it is like 0.084 or something, some value. So it will be like 0.084. So out of total area is 1, right? Total area is 1. Out of the total area, 0.084 areas is for Z less than 2. This is how it is calculated. Now Z, this value, from where you will get? From a Z-score table. There is a table, Z-score table. I will talk about it. Okay, so this is about Z-score. right? And also one more point, let's say we know that, okay, for area less than 2 is this area. How about area which is greater than 2? How we calculate? I mean to say, how we calculate this area? This is very simple, right? If you know this area and if you know the whole area, then calculating this is very easy. The whole area is 1 minus P of Z less than 2. So this will be giving the proportion of area which is more than Z equal to 2. So this is all about Z score. We'll do some tasks. Okay, so after every theory, if there is an example, then it will be easier for you to understand. Okay, let's solve this particular task. Let me move in the presentation mode. Okay. Yeah. So here you see question. X is a continuous random variable. So you know now what exactly is continuous random variable. And it has been given a mean of 40. So let's say mean is 40. And a standard deviation is 10. So it's saying mu is 10. What proportion of the observations are less than 50? So in this particular curve, let's say mu is given as 40. Standard deviation is 10. So it will be here 50, 60, 70, minus 50, something like that. Okay. So now we need to understand, or we need to calculate what proportion of observations are less than 50. So if this is the area, we need to calculate this area. By the graph, if we know this, right? This is the graph. This is the median. This is the mean, and this is the standard deviation, which is of 10. And we need to calculate this area. How we'll do it? We cannot simply do it with this. Though if it says it looks like a normal distribution, we cannot do it. We cannot calculate it. So we need to calculate Z, which is the Z score. We need to bring down. We need to convert it into standard normal distribution. Then only we will be able to calculate the probability. Okay. So Z will be what? Z is nothing but X minus mu by sigma. What is X here? X is 50. So 50 minus 40 divided by 10. It is what? 10 divided by 10. So it is 1. So we need to find an area which is less than 1, right? In this case, less than 50, meaning Z should be less than 1. So in this curve, in the standard normal distributive curve, we need to find an area which is less than 1. And this we can do with the help of Z table. So we have something called as Z score table. Sorry, Z score table. So I will show you the table. With the help of this table, we can know what is the area that falls under this particular range. Now let me straight away go to that table. Okay, so you can search it in the Google. Basically, in the Google, you will be able to search for Z score table, and there's a website called ztable.com where you will be able to find out the Z table. So to give you an idea, so these are basically the scores, and this is after the decimal. What is the value? Let's say for this one, it will be minus 3.41, or Z will be equal to minus 3.42, minus 3.33, like that it will be. And this is the area. These are all the area, probability of the area under that particular curve. Okay, so our example, if we see, if you see, we have to find out an area which is less than 1. So we need to find out z for z is equal to 1. So let's see. So z equal to 1, meaning it is minus. So if we go here, 1 is probably this one. So this is 1, and since there is no more further decimal, so we will consider this. So 0.8413 is the particular proportion of the area that will be under that particular curve. 0.8413. So let me go there. So this means this particular area will be 0.8413. Okay, we need to calculate. So value of z is z equal to 1 is 0.83, right? And this is the area under that particular curve. So meaning 84%, 84.13% of the data will fall under this area, will fall under the observations which are less than 50. So if any observation is less than 50, means that 84% of the data will fall under this particular area. Or we can say 84% of the data will be less than 50. 84% of the data will be less than 50. Now similarly, we can calculate this one also less than 20, right? So how we calculate? It's the same formula, guys. And we'll refer to the same Z table score. Let me run this. Okay. So here now, in this case, Z will be X, let's say 20, 40, 10. So minus 2, right? Minus 20 by 10 is 2, right? So Z minus 2. So we need to see in the Z table where it's minus 2. So let's go there. Let's go over to the Z table and search for minus 2. So minus 2 will be this one, 0.228, 0.0228, right? So if we go back, so this one will be probability of this one less than minus 2 will be 0.228%. So if we draw here, this is mu, this is 0, this is 1, this is 2, this is 3, this is minus 1, this is minus 2, and minus 3. So you see here, only this portion are we talking of. So only 2.28% of the observations will be less than 20. Okay, so will be less than 20, only 2.28%. So we are able to know the proportions of the observations that will be less than 50 and less than 20. Similarly, we can calculate this one also. So I will leave it to you guys to find it out. Okay, so for what you will do, first of all, you will try to calculate Z for 20, then you will calculate Z for 50, and then you will divide or subtract from 50 that 20, and that will give you the particular area. So if I draw it here, let's say this is for 50, right? And this is for 20. So you need to calculate this area. How you will do it? This is for entire 50. And this is for 20. So if you subtract 50 minus 20, you will get this area. So between 20 and 50. So I will leave it to you. Okay. So you try to find out. You refer the Z table, calculate the percentage, and then you will understand how to do it. Let's take another example. This one. If a birth weights in a population are normally distributed with a mean of 109 O's and a standard deviation of 13 O's, what is the chance of obtaining a birth weight of 130 O's or heavier when sampling birth records are done at randomly? So the question saying is that we have a population where we have a mean of 109 and standard deviation is 13. Now we want to find out what is the chance of obtaining a birth weight of 130 or heavier when we draw out samples at random out of that population. So how we'll do it? Again, Z formula. Z is equal to X minus mu by sigma. So here X is 130 minus mu is 109. Standard deviation is 13. So let me calculate it by calculator. So just give me 1 minute, guys. So let me calculate it. 130 minus 109 divided by 13. So it's 1.62. Okay. So the value that we got is 1.62. Value that we got is 1.62. That's for Z. So let's see now. Okay. Let's see in the Z table what is the value. So we go to the Z table. 1.62. We search for 1. So this is 1.6 and 2. We need 2, right? So 1.6, 2 is here. So 1.6, 2. So basically, you know, right, how to make it 1.6 plus 0.02. So it is 1.62 only. So these are after the decimals, after second place decimals. So we need to find out 1.62. So 1.6 is here, and we need to go here and we see the area. So it's 9474, 0.9474. Okay, let's go back. So it is 0.9474, right? But what is asked here, we need to find out chance of obtaining a birth weight of 130 O's or heavier, meaning we need to find out this 9474. Now I told you, right, how to find out this. It is nothing but the whole area is 1. So this particular value that you got is for P probability of this less than 0.9474. Or sorry guys, P of Z less than 1.62. Less than 1.62 is this one, this one. So we need to calculate Z greater than 1.62, right? Or we can say 130 here. So we need to find out P of X greater than 130. Either you say this or you say this, Z greater than 1.62, because we have converted our normal distribution to standard normal distribution. So now we will say PZ greater than 1.62. So PZ greater than 1.62 is nothing but 1 minus P of Z less than 1.62, because the whole area is 1. Right? This is one of the characteristics. The area, the whole area, this whole area is 100%. Or in other words, we consider it as 1. So 1 minus probability of Z less than 1.62. What is it? 0.9472. So 0.9474. So if we calculate it again, it will be, just a minute, guys. Let me share it again. Yeah, it will be 1 minus 0.9474. It will be 0.0526. So it will be 0.0526. So it will be 0.0526. This is, it means 5.26. So what is the chance of obtaining a birth weight of 130? It will be 5.26%. This is what is the percentage. This is a probability, sorry. This is a probability, or you can say percentage as well. So again, the second question, what is the chance of obtaining a birth weight of 110 or lighter? This I leave it to you, find it from your own. Okay, here we are not finding heavier, so we are not calculating PZ greater than. We are calculating P less than something. Something will find it after you convert it into standard normal distribution. So I leave it to you guys to do this task. Okay, this will be the same. This task will be the same as the previous one that I explained. Okay, so this is all about our Z score and the maths behind the Z score and some of the examples that we did. Now let's go back to our class. So we have discussed everything, I guess. Yeah, we have discussed everything. Only thing remain is sampling methods. So let me go to the other screen. Now let me talk about sampling methods. Sampling. Now we talked about taking random samples from population, right? So we have a population, let's say, population of this many people. And we talked about taking a sample from this, right? In my last discussion, I said, right, let's take a sample of this. So this is nothing but sample. Now there is a way to take out the samples, random samples from the population, and that is done through sampling. And there are three methods, then majorly three. There can be others, but for now, let's talk about three methods. One is random sampling. The other one is stratified sampling. And the other one, the third one is clustering. Okay, so random sampling, stratified sampling, clustering. What are these actually? So guys, one more one more point. The point is here we're discussing how to take out samples. Okay, let's say we have a population of 100 people. We want to take out 50 from them as a sample. So how do we do it? How we do the sampling? So these are the three techniques: random sampling, stratified sampling, clustering. So in random sampling, what we do is, let's say we have a population of many people, let's say 100. Okay. So in random sampling, what we do, for every, let's say 100 is a total number of people, total number of observations. So what we do, we assign random numbers to each of these persons or each of this observation, let's say. And then we use a random number generator, and we generate numbers. Let's say we want to generate numbers from 1 to 10, right? So we will have few numbers, right? So, and we allocated already numbers to each of this person, let's say. Let's say here it is 1, let me use a different color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. So we assign random numbers to each observations. And then we define a random number generator. In this, we give a range. Okay, I want numbers from 1 to 10. So it will, let's say it collected 4 of them, 2, maybe 3, 7, and 9. So 2, 3, 7, 9 will come from here and it will be collected as a sample. Okay. In the next iteration, let's say again, they say, okay, find out one number, four numbers, but they change the range, let's say. So again, it will go and it will not collect the same, or it may collect, but again, it may go and collect different groups of people based on the numbers that it generates. Let's say this time it generates 5, 9, 11, and 13. So it will go there. It will see what are the observations that are tagged with 5, 9, 14, and 13, and they will collect them and make them as a sample. This is how random sampling works. Randomly, they are generated. Okay, so now let me talk about stratified sampling. What happens in stratified sampling is we divide, first of all, we group the users. So let's say we have this many people. Let's say we have this many people in a population. So first of all, we group them. We group them based on their demographics. Let's say these are girls, these are boys. Okay, so based on the gender, it can be one group. Then let's say based on their income, this can be another group. Who are earning more, who are earning less, who are earning in the middle range. So based on them, we can create another group, right? And then we take equal proportions of persons from each of these groups. Let's say we first of all created the group based on gender, male and female. Okay, so there will be two groups. Then we'll take five males from here and 5 females from here, and we'll create a sample. Like this, let's say we created a group based on income. Let's say there may be many groups. So we'll take again, let's say 5 from a group who are earning less than, let's say 50,000, and people from this group who are earning between 50 to 100K, and this group greater than 100K. And we'll create a sample. So in this way, you see, we do stratified sampling. Now, what is clustering and how it is different from this stratified sampling? In stratified sampling, we created the group which are homogeneous in nature, right? This is important. Homogeneous in nature. What is homogeneous? Meaning similar in nature. So all the females have similar characteristics, right? They are females, and all the males will have similar characteristics. They are males, right? So we collected in this form. Clustering is different. Clustering is like we have a population, let's say, and irrespective of the genders or irrespective of the demographics, we try to see what are the behaviors of this group of people, and then we classify them or we group them. And then we collect samples from each of these groups. Now, when I say behavior, what does it mean? What does it mean? Let's say this groups likes to, okay, so let's say we're trying to sample the data for different movies. Okay, how we will classify, how we will take a sample. So first of all, we group them. Let's say this group of people like maybe romantic movies. So we'll categorize them in one group. This group of people like sci-fi movies. We'll categorize them in one group. And then this particular group of people like horror movies. So we'll categorize them in one group. And then from each of this group, we'll collect different samples, different observations, and create a sample. And then we will try to get reviews, let's say get reviews about the movies or about the movies that are trending. So this is the way we do clustering. Now, one important thing to note here is, guys, when you're doing a sampling, it should not be a bias sampling. Now, what is bias sampling? Bias sampling means, let's say you want to do a survey of people who smoke. Okay. Now you have a population. Let me rub this. Let me rub a few portion of it. Okay. So let's say you want to do a survey of people who smoke in a particular area. Now this area may have different segments of people who are smoking and who are not smoking as well. Let's say you went there and collected a sample of those people who don't even smoke. And now you want to get a review whether smoking is good or bad. What will happen? They will all give you negative comments, right, about smoking. Though don't take it in other way around. I'm just giving an example, but try to understand the whole point. So if you collect samples from those guys who do not smoke, then always you will get a bad review. Right? In this case, you have a biased sample. So when you're doing a sampling, you should not take any biased data, or else your observation or your predictions will be influenced. So we should not do that. Okay. So this is all about sampling, guys. So now we have covered quite a few topics in today's class. In next class, I will talk about something called T distribution also. So this is Z distribution. Another one is T distribution. So I will talk about T distribution. I will talk about central limit theorem, and also I will talk about some other distributions as well. So it will be covered in the third tutorial of basic statistics. So that's it. Thank you, guys. And do let me know in the comment section whether you like this video or not, or if something you need in a better explanation, also you can let me know. Thank you, guys. If you like this video, please share this video. Do subscribe my channel. Thanks a lot.